integration. So basically we know how we can do integration by paper, but when it comes to the programming we will have some confusion. So I will show a small integration here using Python. So let's dive into the topic. Basically I am using these three libraries for today's demo, and I'm having NumPy and Matplotlib installed already, and also I'm using the scipy library in the Python. So basically this is where the integration will be done, and we have created a function which is e to the power of x plus x squared plus 5x plus 1, and we have a function to do the integration as well. So I am using the function as a parameter, and also upper bound and lower bounds, and the access which we are using to show in our plots. So let's look at the implementation. So basically I'm dividing the upper bound and lower bound limit by 100 points, and then I am creating the y coordinates by calling the function on top of the x values. So I'm doing the calculation of y coordinates. Then after that I'm using those to show the plots. So this is basically used to show the plots, and once we have the function and upper bound and lower bound, we can create the integrals value. So for that one I am using the integrate function in the scipy module. So this is using quad integration. So basically there are different methods, Newton's method, Simpson's method, like that. So here we are using a general integration pattern, quad integration, and then I'm going to show the plot using this x, y, and definite integral value, and I'm going to visualize that in a graph. And once we have that visualization, we can see what exactly is the functions work, and how it's displaying the integrals. So for that one, for first value I am using this as a first function as e to the power of x plus x squared plus 5x plus 1, and lower bound is 0 and upper bound is pi. So I'm using the label as similar to the function. Let's execute this one. Okay, let's look at this graph. So here you can see we have a increasing pattern. Basically e to the power of x plus x squared will follow over increasing patterns. So you can look at the coordinates also. When the coordinate increases, the y values are increasing exponentially, and you can see the definite integral value is displayed on top. So I am using this as the title value. So whole the area will be considered as integrated value. So this sum of the area is the total integration. So basically integration is nothing but the area under a curve. So that's the whole point of doing integration. So when you look at this graph, you can identify this plot covers nearly 0 to 3.14 up to the recurring decimals, because the pi is nothing but 22 by 7 approximately. So that's why we are having the plot from 0 to 3.14, and when you look at this pattern, you can see we have a way of identifying how these areas are divided. So this is another method, we will discuss that further. So this triangular rectangular strips will be the ones which will be used in different integration methods, so that we will discuss later. So let's try to change and execute the formula again. So I will modify this formula to x to the power of 5 and execute it again. So let's execute this one and see. Okay, now you can see there is a slow steady start, but it's increasing heavily on the latter coordinate. So this pattern is because of this x to the power of 5 component. So we can visualize different equations and we can see the definite integrals. So hope this is useful program, so you can utilize this and try to create your plots for different equations. Thank you.